Welcome to one and all. This is the physics experiment related to light, and we are focusing the light and the illuminated object based on the lens. Okay, this type of lens you can also use convex lens as well as biconcave convex lens. Now for the operators we needed, it's an illuminated light that is small width. Inside this is a sodium vapor light, and this we will consider as an object, and this is a lens stand, and this is lens where we can keep it as a convex lens, and screen, and also the mirror which is mounted on the screen. You keep a scale beside that to measure the U and V of a lens. Now first of all we need to focus all the illuminated ray of light should be focused on the screen, so that invert that the longest and farthest object that should be inverted on the screen. So now we need to focus it at, so the inverted image has to fall on the screen. So let us move the screen as well as the stand lens. Focus until the inverted sharp images should be fall on the screen. This is the sharpest image of the building, which you can see that inverted image through the lens, and this lens always should be vertically straight. Now you can see the sharpest inverted image has to fall on the screen. Now next we need to switch on the object. This we consider as a sodium vapor light, and that should be incident on the convex lens. Now behind that we can also place a stand which is mounted, so that the image which is focused on the lens that should be falls on the screen of the mirror, that should be reflected on the object. So that we need to consider the image distance, and the object distance we consider as where we keep the lens. Now let us move the lens as well as a mirror. So until the sharp images should be comes and falls on the illuminated box. Now you can see the sharpest image which is reflected through the lens. Okay, and we kept the mirror also. Through the mirror the object will be the sodium vapor light, and that will be reflected back on the same position of the object. Now that is we are considering the focal length of this experiment. Now we have to mark it out the distance from the object to the lens. Okay, now the distance on the object is 18 centimeter, and the distance on the lens is exactly 30.5 centimeter. Now take the difference between these two, and that is the focal length of the given lens. This is a set of the experiment that we are observing how the lens shows the reflected image on the object. Thank you.